This is an example of our time shift property. X of n is equal to 5 to the negative n u of n minus 2. And so the question is to find its DTFT. First step in this is to say we don't see any transforms that look like this negative n. So the closest transform that we can find to this is that a to the n u of n has a transform of 1 over 1 minus a to the e to the minus j omega. We want to somehow convert this negative n thing to a positive n. So we can do a little bit of algebra there and convert that over. If we want to use the property that has the shift things, and remember the property that has the shift things is shown to the left over here, we can't because we've got a n negative 2 over here and we've got just a plain old n over here. So somehow we need to convert this. I'm going to take away the equal sign for a second since this is not equal to it. This is what we could convert. If we knew this, we would be set. And I think it's pretty clear that this, if you multiply out the exponent, becomes this. I'm going to draw just a line here to show that we're working with something else. This is what we can transform. And we can transform that because when you see this, you think of a being 1/5, and so that would correspond to a 1 over 1 minus 1/5 e to the minus j omega. And then since we've delayed everything by exactly 2, that corresponds to multiplying it by an e to the minus j omega 2. So this we can transform. That is equal to this. That is not equal to what we're given, but we can make it equal to what we're given if we multiply it by a 1/5 to the positive 2. We can say that I know that this part that I've underlined is the same part as this that I've underlined, which is the same part as this that I've underlined. And so all that has to have, the yellow part has to be what we figured out up on top. And then to add this section over here, by linearity, that's just the same as multiplying it by that. And so now that we've multiplied our 1/5, we can do that all the way through. And now we can indeed say that everything on the right is equal to everything on the left. And so the DTFT of what we were asked to find originally, the DTFT of this in the upper left, is in the lower right. A lot of algebra there. Just think about how far you've come since, say, circuits 1. Imagine seeing something like this in circuits 1 and just saying, yeah, okay, that's how it goes. We're good with that. Okay, next I want to talk about DTFT symmetries. Yeah, let me review really fast what we did here. Given this is the closest we can find. We want to get a positive exponent, so we convert this into a positive exponent. I see immediately that it's a shifted version over here, but it's not shifted over here. So I don't know how to handle that. So I make it shifted. And then I undo this 1/5 to the negative 2 by multiplying it by 1/5 to the positive 2. I close my eyes to the fact that I've got the 1/5 to the positive 2, and now I can transform everything under yellow to everything under yellow on the right. And then my last step is to multiply both sides by that 1/5 squared to undo it. And then this is the DTFT of my original waveform.